Hello, my name's Jacob, and I'm going to be showing you how to estimate instantaneous rate of change of an x value in a formula. So to start off with, I'm going to give us a problem from our homework. This is question 5 of the My Open Math 2.1. All right. So what we were tasked with was finding the value of the instantaneous rate of change at 2 using this formula here, h of t. So in order to do this, I like to start with finding two values that I can use that can approximate that can get us between -2 on both the positive and negative side of the aspect. So we're supposed to find our limit of t below -2 and our limit of t above -2. So the two values I decided to choose just to get us within 3 decimal spaces of our target instantaneous range is -2.001. Whoops. There we are. And so plugging this value into our h of t gets us a value of 1.33377. Nice accurate number. And then finding our limit t -2, our above limit, we'll input -1.999. And that should hopefully get us enough of a value to estimate to 3 decimal places by the end of our calculations. So plugging that in, we get 1.332889. Taking both of these values, we'll go ahead and put those into our second step, which is then finding our delta H of delta T, and that will be 1.3377.332889. Plug those in. And so we'll use our delta H values will be our outputs for H of -2.001 and H of -1.999. So these two, and then our delta T values will be down here. So calculating this out, you'll get out, for putting this in at H of -2, will get us -0.4405, and then this will give us our final answer of our formula. So taking it through, when we want to find a instantaneous value of a formula at a specific value, so in this case -2, we find our upper and lower limits for those values. So in our case, at -2, we will have -2.001, and then for our upper value, -1.999. We then take that, we put it into our slope formula, so delta H over delta T. That'll give us our rate of change, and it's not going to be exact, but it'll be as close as we can get it. The bigger these numbers are, the more accurate it's going to get for us. And we were able to get it down to 4 decimal places. So that gave us -0.4405. And then that is how you calculate the instantaneous rate of change of an x value in a formula.